In this video, we're going to talk about solving right triangles. So that means that first you got to make sure your calculator is in degree mode. So that's when you go to second mode, or it's right next to the second button. It's the mode button. Make sure that the degree word is highlighted, and that makes sure that all your answers will be in degrees. Next, to solve a right triangle, that means we need to find all the missing angles and all the missing sides in our triangle. So one thing that could come up with the sides is we might have to use Pythagorean theorem. We could also use one of our trig functions. For the angle, sometimes if we are given one of the numbers, like if this is 30, then we know that the other one would have to be a 60. So sometimes you don't have to necessarily solve for the missing angles in different ways from what we had done before. So next, with the inverse function, this is what we have to use if we have to find the angle measurement. If you don't have any angles whatsoever, is that we need to use the inverse button on your calculator. So to get the inverse tangent, you have to go second tangent, and then that will show up. If you want the sine, you have to do second sine. If you want to do the cosine, you would do second cosine on your calculator. And if you look in your calculator, it's in blue of the part that you do want, so you're going to have to make sure you type that in correctly. So if you notice that the angle A is the part that we're solving for, so the X is what will go inside the parentheses, or here the Y goes inside the parentheses, or my Z goes inside the parentheses. So you'll see that more when we work out these questions. In this triangle, we're going to just use the calculator to approximate the measure of angle A to the nearest tenth of a degree. So remember, we have to label our sides. So if you see already in my picture, I have 15 is opposite of my angle A. The 20 is adjacent because it connects it to the right angle. So the function that uses opposite and adjacent is the tangent of A. So we need to use the tangent of A equals, and then remember, tangent is opposite over adjacent, so that would be 15 over 20. Then because we need to solve for this angle A, that I need to do, the angle A is going to equal, and this is where the inverse comes in. So I have to do the inverse of tangent of that 15 over 20, and make sure you close off the parentheses in your calculator. So when you do that, we get about 36.8699. So remember, we want to go to the 10th place. That'd be right there. So this would be 36.9 degrees would be my angle A. All right, so I'd like you to try it on your own now. So you're doing it based off of angle C. So remember, the 20 is now the opposite. Your 15 is your adjacent that you will use now for your angle C. So go ahead, push pause. When you're ready to check your answer, go ahead, push play. All right, so again, you will use the tangent of your angles of angle C, your opposite over adjacent, so that would be your 20 over your 15. So the way to solve your angle C then, you're going to have to do your inverse of tangent of the 20 over the 15, and that gave you 53.1301, and you want to cut it off right there. So this would be 53.1 degrees for your angle C. So in this question, you can see we've got a picture right here. Our 2 is in relation to our X, so that would be opposite. And our 30 over here is going to be our hypotenuse no matter what. So the one that uses hypotenuse and opposite is our sine. So we need to do our sine of X equals our opposite over hypotenuse. So that would be our 2 over the 30. So remember, we need to do the inverse of sine to find our angle X. So remember, your calculator needs to be in degree mode. And once you type this part into the calculator, you end up with a 3.82. So we're going to say that that is a 3.8 degrees for that angle X. So now I want you to try this next one on your own, and I want you to push pause, and when you're ready to check your answer, you can push play. In this question, this is what you should have so far. So if you notice, I've labeled the opposite of that angle x, and I labeled the hypotenuse of my angle x. So the one that uses opposite and hypotenuse again would be my sine. So you should have done the sine of x equals your 3 over 35. So you should have typed in the inverse of sine in your calculator of 3 over 35. And this would have gotten you 4.9 degrees. Sorry, that's a little sloppy. In this triangle, we have to solve the right triangle, so that means we need to find all the missing pieces. So first off, we see that there's an angle B that is missing. We have to find that. We also see that there's a side CB, and I'm going to label that as side X that I'm missing to make it easier when we find everything, to give myself some labels. And let's see, we are also missing side AB, and I'm going to label that as my side Y over there. Okay, so even though I'm going to find my angle B, my 42 is still going to be my kind of baseline. So this is the opposite. This is adjacent, and this is going to be my hypotenuse. Okay, so for my angle B, this is probably the easiest one to use just because we can add up all of our missing angles, or all three of our angles in our triangle, to equal 180 degrees. So when I do that, my angle B equals 48 degrees. All right, so for side CB, I can see that I am going to use opposite. I also need to use adjacent because that's the side I'm given. So the part that uses opposite and adjacent is the tangent. So I'll be using the tangent of my 42 equals my, let's see, my opposite, so my x, over my adjacent, so that would be my 70. So remember, when we solve this, we need to put it over 1. All right, so put it over 1. So I can cross multiply, so I'll get 70 times the tangent of 42 equals my x. So when I multiply this part in my calculator, I get that my x value is 36.016. So I'm just going to do 36.02. I don't want to put 36, otherwise it looks like it's exactly 36. So then we do the same thing now for the third side in the triangle. So we could use Pythagorean theorem, or we could use our trig function. So I'm going to use my trig functions again. So this uses hypotenuse. And again, I'm going to use my adjacent since that's my 70 and it's exactly 70. So hypotenuse and adjacent is my cosine. So cosine of 42 equals my adjacent, so 70 over my hypotenuse. Or I need to put this over 1 so I can cross multiply. So when I do that, I get y times the cosine of 42 equals my 70. So I need to solve for the y by dividing by the cosine of 42. So I have 70 divided by the cosine of 42. And this gives me, for my y, let's see, we get 94.194. So this would be 94.2 would be my hypotenuse and my side AB. So I'd like you to try this now on your own. So draw in the 40-degree angle, and it doesn't matter which angle is related to 40 degrees. Let's make this angle down here my 40 degrees, and that way we all have the same answer. And then you want to find your angle B. The 20 is your hypotenuse. So there's your 20, and you need to find the other two sides. So go ahead, push pause, work out your answer. When you're ready to push play. When you're ready to check your answer, you can push play. All right, so I did the first one already for you. So angle B is going to be 50 degrees. Next, to find the y, so side AC, we have adjacent, and we're going to need to use our hypotenuse since that's what we are given already. So adjacent and hypotenuse is our cosine. When I cross multiply now, you can see that we need to take our 20 times the cosine of 40 and y times our 1. So when you type this into the calculator, so 20 times the cosine of 20, we get 15.321. So 15.3, and that'll be in inches, and that will be for our side AC. So next for your side BC, when we do the sine of 40, because we have opposite and we have hypotenuse, that we need to do sine of 40 equals x over 20. We need to put it over 1 and again cross multiply. So we get 20 times the sine of 40. So that means that our x value over here, so my part in green or side BC, will be 12.856. And since we want to round it to the nearest tenth, we're going to do 12.9, and that would be inches again. And that's for my side BC there at the end. Alright, so we saved almost the easiest questions for last. This is mostly just purely on the calculator. So this is so that you can find, if you are given this, we need to find the measure of angle A. This means that we're taking the inverse of sine of 0.87. So you just have to type that in on the calculator, and we get 60.4586. But we're rounding to the nearest tenth, so again we're stopping after the 4. So I'm going to write 60.5 degrees for my measure of angle A. So go ahead and you work it out yourself for the next one, and then check your answer. Alright, so on this next one, you should have done the measure of angle B equals cosine inverse of 0.15, which then should have given you 81.373 around. So we're cutting off after the 3. So it'd be 81.4 degrees for our measure of angle B. This question is a bonus question. You can earn some bonus points, 2 major grade bonus points if you saw this correctly in your notes, and show me when you check off your notes. So it says an airplane pilot is taking off on a runway and needs to reach a cruising altitude of 10,000 feet off the air, or off the ground. He flies for 30,000 feet through the air, and notice that's not the ground distance, so that's not the horizontal distance, that'll be through the air, so more the hypotenuse. And you need to do that to reach the 10,000 feet. And you need to figure out what angle, so you have to do your inverse function, that he needed so that he could take off. And notice you need to put a picture with your sides all labeled, so with your opposite, adjacent, hypotenuse, also with the numbers in there, so your 30 and your 10,000 feet. You know, show me which equation you use to set it up, and then show me the correct solution. So you have to do all 3 of those parts to get your 2 bonus points.